All right, so you've just finished a physics exam. You walk out feeling pretty good, but then you get your results and it's not quite what you hoped for. You're thinking, I knew that stuff. Where did my marks go? Well, if that sounds familiar, you're in the right place. Today, we're going to pull back the curtain on the AQA GCSE Physics mark scheme. We're going to turn it from this, confusing document into your secret weapon for acing those exams.
I mean, this is the big one, right? You've spent weeks, months learning all the physics, but what does the examiner actually want you to write down? It can feel like they're speaking a totally different language. But here's the secret. They've already given you the answer key. The mark scheme is basically a cheat sheet, and it tells you exactly what gets you the points. So let's learn how to read it.
Okay, here's how we're going to do it. First, we'll crack the examiner's code. Then we'll look at the secret language they use. We'll dive into 2 case studies, one on forces and another on moments to see it all in action. And finally, I'll give you a mark maximizing toolkit to take away. Sound good? Let's jump in.
Right. Let's get one thing straight. The mark scheme isn't some top secret document just for your teachers. No way. You should think of it as your treasure map. Seriously. The people who write the exam questions also write the mark scheme, and it's literally a step-by-step guide to where the marks are buried. If you learn how to read this map, you're going to find that treasure every single time.
So, to read our treasure map, we need to understand its language. It's got its own set of symbols and keywords, a kind of examiner speak. And these words have super specific meanings. Once you get the hang of them, I promise you'll start to see exam questions in a completely different way.
Okay, let's kick things off with a nice, friendly one, the word allow. When you see this, it basically means there's more than one right answer. It's the examiner saying, hey, if you said it this way, that's cool too. So for instance, maybe they're looking for the word mass, but they'll also allow you to say weight. It just gives you a little bit of wiggle room, which is always nice.
All right, next up is ignore. Now this one sounds a bit harsh, but it's actually not a bad thing. It just means you've written some extra stuff that's, well, irrelevant. It's not wrong, so you don't lose any marks for it, but it's not getting you any marks either. It's like a little nudge from the examiner saying, okay, that's nice, but you need to add the key information to score here.
Okay, pay close attention now, because these next 2 are absolutely crucial. First, if you see 2 things joined by a big, bold "and," that's not a suggestion. It means you have to write both of those things to get that 1 mark. It's a package deal. And then there's the underlined word. If you see something underlined, that is a non-negotiable, must-have, essential key word. You've got to use that exact word. No substitutes allowed. It's a deal breaker for the mark.
So, here it is, your official examiner speak decoder ring. We've talked about most of these, but let's just focus on that last one for a second. ECF. This stands for error carried forward, and honestly, it can be a total lifesaver in calculation questions. It means that even if you mess up the first part of a calculation, you can still get marks for the next parts as long as you use your wrong answer correctly. How great is that? It's like a safety net.
Okay, enough theory. Theory's great, but let's see how this stuff works in the wild. We're going to take a look at a real question about forces from an actual AQA paper and put our new decoding skills to the test.
All right, so here's the scene. You've got a trolley on a little runway, and it's tied to a mass hanger by a piece of string. Simple enough. And the question, for 1 mark, is just, what's the name of force F, the force in the string?
And the mark scheme, 1 word, tension. That's it. Not the force of tension acting through the string, just tension. This is such a key takeaway. If the question asks you for a name or a single word, just give them that. Don't overcomplicate it.
Okay, on to the next part. 5.2 asks us to name 1 variable that should have been kept the same, a control variable, to make sure this was a fair investigation. So, have a think. What needed to stay constant here?
And check this out. This is where our decoding skills really pay off. The mark scheme says the answer is the combined mass of trolley and mass hanger. See those brackets around combined? That means the word is extra detailed, but you don't strictly need it for the mark. And then look, there's our old friend allow. They'll also let you have the mark for just saying mass of the trolley or even weight of the hanger. This is a perfect example of how knowing that language gives you more ways to be right.
That was a fantastic start, but that was just a small part of a question. To really get a feel for how these marks stack up, we need to look at a whole question from start to finish. So let's do a deep dive into another one, this time all about moments. Okay, first part, 2 marks up for grabs. The child is still, what is the resultant vertical force and why? So mark number 1 is for the what. Since the child isn't moving, the resultant force is 0. Simple as that. Mark number 2 is for the why, and for this you could say the forces are balanced or the child isn't accelerating. See that structure? 1 mark for the answer, 1 mark for the reason. Classic 2-marker. Now for a 3-mark calculation. And listen up, because this shows exactly why your teachers are always telling you to show you're working. You get 1 mark just for writing down the correct equation. 1 whole mark. You get a 2nd mark for plugging the numbers in correctly, and then the 3rd mark is for the final answer with the right units. This means you can literally mess up the math on your calculator and still walk away with 2 out of the 3 marks. Always, always show your work.
Here's another great 2-mark explain question. These are almost always about cause and effect. Think of it like a chain of events. Mark 1 is for the cause. The resistive force is decreased. Okay, so what? Well, that leads to the effect, which is your 2nd mark. So the resultant force increases. You need to state that logical link to get both marks. First this happens, then this happens.
Another calculation, but this one has a sneaky little trap that catches so many people out. Look closely at the distance. It's in centimeters, but for the moment equation, you need it in meters, and the examiner knows this is a common slip-up, so they actually give you 1 full mark just for converting 7.5 centimeters into 0.075 meters. It's probably the easiest mark in the whole question, but you've got to be looking for it.
And for the last bit on this question, we're back to a 2-marker about gears. And again, think about making 2 separate clear points. Your first point and your first mark is for describing what happens. You could say gear B rotates the other way, or that it rotates faster. Your second point is the why, because gear A is pushing on it, exerting a force. Boom. What and why. 2 points, 2 marks.
Whew, okay, so we have totally decoded the secret language of the examiner, and we've seen it in action in real questions. Now, let's wrap all this up into a handy little toolkit, a set of golden rules that you can take with you into any physics exam. All right, here it is, your mark maximizing toolkit. 5 simple rules. Rule 1, learn the keywords, especially those underlined ones, they're gold. Rule 2, show every single step of your calculations. You'll thank me later. Rule 3, think 1 point per mark. If it's a 2-mark question, you need 2 distinct ideas. Rule 4, answer the actual question they asked, not the one you wish they asked. And finally, Rule 5, double-check your units. A tiny MRS can be the difference between a mark and nothing. Seriously, if you can get these 5 things down, you'll basically be thinking like an examiner.
So there you have it. The mark scheme isn't the scary, mysterious thing anymore. It's your roadmap. You now have the code, you know the language, you know exactly what they're looking for. The only thing left to do is practice. So grab a past paper, get the mark scheme out right alongside it, and see which question you're going to conquer next. You can absolutely do this.